As generative AI is still a relatively new technology, there remains considerable debate about how to best integrate these tools into the CS curriculum. My experience with this began by co-writing a book on how to learn to program with generative AI with my colleague Dan Zangaro. We then turned that book into a course at UC San Diego and have taught hundreds of students how to program with generative AI. But you might be asking, why should we integrate GenAI? And I'd like to briefly offer 3 reasons why CS educators should actually be motivated by the prospect of integrating generative AI tools into introductory programming courses. First, it's clear that industry is using generative AI tools. In the news and in recent research studies, we've seen that these tools are changing how professional software engineers program. We've heard that GenAI is making software engineers more efficient than ever before. We've heard that GenAI may help lower barriers to entry into the field. We've learned that sometimes 30% of code at major companies is being generated by GenAI, and even higher fractions at recent startup companies. So if we want our students to have the skills to succeed in the modern economy, they are going to need to know how to use generative AI tools effectively. Second, I'd like to review how we, as a community, have landed on Python or Java in the past decade as our default language in introductory programming courses. My PhD is in computer architecture, which is the high-level design of modern processors. From that perspective, Python and Java are quite far removed from what actually executes on a modern computer. I mean, Python goes through an interpreter to produce assembly code, which then goes through an assembler to make machine code, and machine code is what really executes on a processor. And there are lots of computational ideas that I view are fundamental at those levels, and these include stack layout, pointers, dynamic memory allocation, system calls, and many others. And these are all lost in languages like Python and Java. Even pointers, the primary way that we interact with memory, have been mostly hidden from students in Java and Python. And Python is slow compared to similar C code. But we've decided as a community that it's okay to lose performance and to hide some of these fundamentals for a reason. Python and Java seem to be easier to get started with as a programmer, and because of their extensive libraries, it's easier to do something important quickly. And if we apply that same logic, isn't this the next step? To interact with computers in an even easier to understand language than Python? With prompts, we're interacting in a human language that is no longer tied to syntax or even a single human language. Although it's tempting to just move to prompts entirely as a primary interface, there is an important catch. Unlike interpreters processing Python code, GenAI can be wrong. This means that students still need to learn computing skills. It's just those skills may be different than the skills in the past. For example, we believe students likely need to spend less time learning how to generate code than in the past, and more time learning how to read, test, and debug code. Third, I'd like to share that I think generative AI is an opportunity to correct some long-standing issues in computing. I also like to be accurate in the comparisons that people make when we're comparing courses. I talk to a fair number of instructors who want to defend their current classes as being where students really learn to program. But they have to be ignoring their student performance on their exams if they really think that's the case. Our existing CS courses are known to suffer from 2 key issues, among others that are well documented. The first is that there's a well-documented gap in the skills that we teach and the skills that are needed by our graduating students to succeed in industry. The second is that over and over again, we've seen that students don't learn as much as instructors think they should. And let me expand on each of these just a bit. First, let's talk about the gap between what's taught in CS courses and the needs of industry. Now, many papers over the years have identified this gap, and one example of these is there's a study from Michelle Craig and her co-authors where they interview early career programmers about their perceptions of the gap. These former students report, for example, that assignments in school are very well defined versus the kind of open-ended projects they do in industry, or writing small standalone programs in school compared to adding features in large existing programs in industry. Encouragingly, we found from our own research that faculty want to help. They want to improve the curriculum, but there are resource barriers for them doing so. So it's worth thinking about how GenAI might help to lessen this gap. We've already talked about programmers using generative AI tools in industry, so that's one thing. But we seem to be at the end of the road for well-defined, super constrained assignments. And maybe, for example, our students could use GenAI tools to support them as they grapple with an overwhelmingly large code base in order to add a new feature, as students are doing in some of our new courses at UC San Diego. Beyond gaps to industry, for ages, it hasn't been clear that our students are actually learning what we want them to learn. There's a famous problem from the CS education literature called the rainfall problem. It's all about taking amounts of rainfall, as integers, from the input and then calculating the average. You stop and you receive some flag like 99999. Not all research agrees, but it's common for something like half of the students to get this code wrong, even after taking an introductory programming course. It's been hypothesized that part of the problem is a mismatch between the looping constructs offered by programming languages and the ways that people think about loops. Now, more broadly, failure rates in CS1 have been concerning instructors and researchers for decades. And for the students who struggle and fail in these courses, this takes an emotional toll. If the syntax and the constructs of the programming languages are at least partially to blame, what will happen when we reduce the focus on these because of the use of GenAI? This possibility is what excites Dan and me the most about this new technology. Now, some of you may still be tied to the notion that writing code from scratch in Python is the main thing you want from your students, and as such, you may consider banning students from using GenAI in your course. The challenge with this, and this is a point that Dan has made to me repeatedly, is that the tool is there for students to use whether we tell them they can or they can't. And if they naively approach the tool, they might just copy-paste into the tool and then copy-paste back to our assignments without really learning any of the skills that we're hoping to teach. I argue it's better to teach them how to use GenAI tools properly. And there are a number of good ideas in the community about how to do this well, and I encourage you to explore the many resources on this website to help you learn how to do this. Or if you just want to adopt a couple of small pieces into your classes to integrate GenAI gradually, we have suggestions for how you might do that as well. In summary, we believe that students will need to be trained in how to use GenAI to be successful in their careers. Although GenAI make it easier to get started in programming, the skills to program shift when working with GenAI to give more emphasis on skills like code reading, testing, problem decomposition, and debugging. As we revise our courses to teach these skills, we believe this is a rare opportunity to address some of the long-standing issues with the introductory programming courses of the past. All this is to say, if you're interested in learning more about how to integrate GenAI into your courses, you've come to the right place. This consortium is dedicated to helping educators provide course materials, summaries of the research, and a supportive community. We look forward to helping you take that next step.